Number 18, we're going to have to use some partial fraction decomposition. So we have our integral here, dx, x minus 1. And the second term I'm going to factor out because it's easily factorable here. We get x minus 1 times x minus 2. So to combine this a little bit easier, we have x minus 1 squared x minus 2. We have a 1 on top. And that's what we're taking the integral of. So we definitely need to use partial fraction decomposition here. So what are our three fractions? We have a over x minus 1. We have b over x minus 1 squared. And we have c over x minus 2. So this all has to equal this term here. So we can use our multiplication or partial fraction strategy. So if we multiply everything that's needed for each variable, the numerator should equal 1. So this one, a, is going to have an x minus 1 and an x minus 2. b is just going to have an x minus 2. And c is going to have x minus 1 squared. And that all has to equal 1. So we can do this a couple different ways. Since it's really easy in this case to plug in values for x that'll cancel them out, let's do that first. If x equals 1, that gets rid of this because that would be 0, and this. So we get b times 1 minus 2. So we get negative b equals 1, b equals negative 1. If x equals 2. If x equals 2, this would be 0, this would be 0. We're left with only that term. 2 minus 1 is 1. We get 1 squared, so we get c equals 1. That one was simple enough. And for the last part, I can write that down there. For the last part, I'm going to go to the coefficient strategy because a would be the coefficient of x squared here, and c would be the coefficient of x squared here. There has to be no x squareds left. So if c is 1, a has to cancel it out, so a has to be negative 1. You could also get that one by plugging in negative 1 and 1 for c and then choosing just another x. But I like to use the coefficient strategy once you've run out of x's to plug in. So those are all three of our constants. So now we can rewrite this integral in terms of those. So we're going to be integrating negative 1 over x minus 1. We get minus 1 over x minus 1 squared. And then we get plus 1 over x minus 2. So these are all ones that we can just do term by term. So x minus 1, or sorry, negative 1 over x minus 1, that's going to give us negative ln of x minus 1. For this one here, we have a power of negative 2, so we're going to have to use our power rule. If you use your power rule, you add 1 to that power. We're going to get plus x minus 1, or sorry, plus 1 over x minus 1. So then for this one, we're going to get plus ln of x minus 2. And then plus c. So all three terms were able to be integrated individually once you use partial fractions. And this all matches up with answer choice D on your test.